Hi everybody, Dirk here. Welcome once again to the Dungeon Laboratory. I'm testing out this circuit here. It's another little SST circuit that I'm kind of wanted to get around to doing, and I got all the parts in yesterday. So I figured I'd go ahead and build her up. It's kind of like a first light to get it testing. I had to switch around the primary um, connections here and get it going here. I don't think I got a little ATX supply over there. Either that's not pulling or not giving enough power for the circuit, or it could be some other variables. But this is just a really quick and dirty kind of test setup. I got my I guess it's like a push pull type circuit. It's kind of interesting how this is. It's a pretty interesting circuit here. So this is a tefatronix skori SST setup using pretty small little MOSFETs. These are logic level MOSFETs. They run at a lower voltage rating. I think they're like 50 volts, 10 amps or something like that. But they have a lower resistance, internal resistance, so they're much more suited for running smaller Tesla coils. Like this is just a stand-in, my little candlestick coil here, running at a couple megahertz. The output isn't anything great, but I'm just in testing just to see if everything would work. Kind of an experimental GDT here. The ferrite core that I'm using is used for pulse transformers and telecommunications, so it can definitely go up into the megahertz range. It's got pretty good permeability, I think. I don't know. It's just I wound on it's a 1-to-1 transformer, so there's 18 turns on there. I think the schematic calls for 20, but I don't know. I'll have to do some more testing. I do plan on, if I get it, winding up this coil, which is going to be much smaller with 30 gauge wire. It'll give me roughly around the same amount of turns and roughly the same frequency range. These smaller SST coils used in this circuit, they run between like 2 and 4 megahertz, I would assume. So yeah, so I just got the little test rig going up here. So the secondary um, is going through this. It's basically like a feedback type system going through here. So you have one side of the transformer for the secondary, and the other side of the transformer going to the gates. And there's an additional MOSFET over here for an interrupt feature. I'm gonna have to get this built up a little bit more. Like I said, I just wanted to get it going here, and I don't know if the circuit didn't really specify either going to the negative rail of the actual circuit, which I wouldn't really recommend. It'd be much preferred to run this to an RF ground. But considering the how far away my RF earth stake is, it could be it probably could perform better if it wasn't connected to this really long piece of wire. I don't know. I'm not really a big fan of connecting it directly up to the circuit ground here. I could try it really quick. Worst case scenario, my HX supply is just going to cut out. It has a protection features. HX supplies usually have that type of deal. Probably not every one of them do. And I'll get this going here. It's like I said, it's nothing spectacular, but it does work. There we go. Nothing fancy. Probably wigging up my camera just a little bit. There's just a tiny little bit of breakout, but it doesn't sustain. But hey, it works. It's not bad. I think I got the gate voltage just right. It's a tiny little flame. It wants to stay out, but yeah, just won't do it. I think it's wigging out my camera here a little bit. Yeah, it works. Oh yeah, there we go. Not bad little test setup. I'm gonna say because it doesn't have a top load on there, the optimal resonant frequency of this coil would be about 1.2 to 1.3 megahertz with optimal top load. So without a top load, it's probably running a lot higher. I'd say maybe a megahertz more, maybe between 2 and 3. 2 or 3 megahertz, which is fine. You know, it's not a big deal. I don't think these secondary coils use much of a top load. I tried this little top load here. I think it actually made it worse. So yeah, that's that. But you know, just to test this out, I'll get a video up on the YouTubes, because I know the magnetist is quite fond of these circuits, and they seem like really cool little coils, and it has a lot of interrupt possibilities. Or I even have my little um, I forget what it is. It's like a tiny interrupter. It's got some music, MIDI music stashed in there. I'd love to play it through this coil. That'd be really cool to have a small little coil. I already have a similar circuit, but I don't know. This seems like this would give out a lot more output when tuned properly. So I'm gonna carry on here, and yeah, if it gets any better, I'll post an additional video. So until then, cheers, guys.